So we are told that this is data about voters who chose to say that they belong to particular political parties. And we found out that we had the Republican, the Democrats, and the others. So we found out that the people we interviewed, the males who said they were Republicans, were 26. Those who said they were Democrats were 13. And the others who belonged to other political parties and they were male were about 5. Okay? Then those who said they belonged to the Republican and they were female, they are 20. The Democrats were 29 and the others were 7. So we have a claim that uh, there is a claim that belonging to a certain political party is independent of gender. Okay? So a claim is that belonging to a certain political party is independent of gender. Perform a chi-squared test, test the claim. Now we have to look at what is the null hypothesis. The null hypothesis is always obtained from that statement. So there is a claim that belonging to a certain political party is independent of gender. Therefore, the null hypothesis, we can say that the political party is independent upon the gender. So political party is independent upon gender. The alternative hypothesis obviously is always opposite to the null hypothesis. So alternative hypothesis H1 is that the political party is dependent upon the gender. Political party is dependent upon gender. So what does this call us to do? If we are to use the chi-square, we know that the chi-square value, x squared, is equal to the observed values minus expected values. This is the sum of observed values minus expected values squared divided by expected values. Now, we need to look for the totals. So the total for people here who are Republicans, we are supposed to get it, the total for Democrats, the total for others, and then the total for men, the total for female. So we are going to put our totals here. So this is 46, this is 42, and this is 12. Then what about the totals here? 26 plus 13, that is 39, plus this 5, we would have 44. 20 plus 29, that's 49, plus 7, that is 56. And then the total should give you, this is 100. Does this give you also 100? Yes. 46 plus 42, that is 98. 88 plus 12, you get 100. So this gives you 100, and also this gives you 100. So let's go ahead and look for, these are the observed values. These are observed values. So we need to look for what we call expected values. So expected values, since we are having a number of we have males, we have female, we have a number of rows and columns, so we shall also create the expected values of the same. So how can we get the expected value for males? So to get the expected values for males, this is how we are going to do it. Expected values for male who is a Republican, who is a Republican. A male who is a Republican. So this is going to be the expected values will now be the total number of males, which is 44. Okay, you divide it by the total number of individuals. Okay, let me write maybe the formula properly. I say this is going to be males divided by the total. I multiply it by the number of Republicans. So this is going to be, we said the total of males were 44 and the total of all individuals is 100. So we have 44 divided by 100. And what is the total of the Republicans? It's 46. So we have 46. And the value is 2.24 if you calculate it very well. Then you need to also look for the expected value, the expected value for males who are Democrats. So this is also going to be the number of males, which is going to be the total number of males, then the number of males who are Republicans, who are Democrats are 13, then you divide it by the total. So this is going to be males divided by total multiplied by Democrats. So who are male, okay? So this is going to be 44 divided by 100 times the Democrats are 42. The Democrats are 42. And that value should give you around 18.48. Then do the same for others. Expected value for others who are male. Okay, the male others. The male. So we are saying the male others. So this is going to be male over the total times the others who are the others, the total of others, and the total of others is also known as 12. So we are going to have 44 divided by 100 times 12, and that should give you about 5.28. So you come and fill in this table. Here you have 20.24, you have 18.48, you have 5.28. So do the same for females. Expected females, Republican, and that will be females divided by the total. You multiply by the number of Republicans, okay, by the Republicans. So this is going to be the total of females is obviously 56. The total is 100 for all individuals. The Republicans are 46. And the value that you get is 25.76. So you come here and write 25.76. If you do the same for Democrats, you'll have 23.52. Then this other one, 6.72. So kindly go through it and be able to get those values. Now, our task is to get the chi-square. This is the chi-squared value. So our chi-squared value is going to be observed values minus expected values squared. Remember, these are many and you are supposed to sum them, so divided by expected individual values. So this is going to be, you get your 26 minus, okay? Get your 26. For example, for males who are Republicans, you get 26 minus 20.24, you square. You divide it by the expected value, which is 20.24. You add. Now you go to, for example, you go to males, okay, who are Democrats, okay? Males who are Democrats, I'm going to get 13 minus 18.48. I square, I divide by 18.48. I add. For others, it is 5 minus 5.28. I square, I divide it by 5.28. I add now for females. For females, it is 20 minus 25.76. I square, I divide it by 25.76. I add. For Democrats, it's going to be 29, because that is the observed value. The expected value is 23.52. I divide it by 23.52. This is squared. I add for others, which is going to be 7 minus the observed value, which is 6.72. I square, I divide it by 6.72. So when I sum all this, I should be able to get a value, chi-square value, which is 5.86. Now, this is the calculated value. So I'm going to use the table, use the degrees of freedom, and get the critical value of the chi-squared. So how do I get the degrees of freedom? For this kind, if for example I had males and I had Republicans, Democrats, and others, the degrees of freedom would be 3 minus 1. They would be how many observations? It would be Republicans, Democrats, and others. Those are 3. So 3 minus 1, that would give you 2. But now these ones, you have rows, you have columns. You have observations, but you also have the different categories for male and for female. So what we do for this kind of problem, this is how we get the degrees of freedom. You get the rows minus 1, you multiply it with column minus 1. So we know that the rows, our rows are 2, okay? Our rows are 2, so we subtract 1. Our columns are 3, we subtract 1, because when you look at this data that is given to us, the number of rows are 1, 2. The columns are 1, 2, 3. So what will that be? This is going to be 2 minus 1, which is 1, then times 3 minus 1. This is giving you 2. So we go to the table for chi-squared values and look at the degrees of freedom 2. So I'm going to come here and check on 2. And what is the value of the chi-square at 5% level of significance? I said we always check if it is not mentioned, the level of significance, if it is not mentioned, we always take the 5%. So I see at the degrees of freedom equaling to 2, the chi-squared value, you check on the table, and the table is supposed to be showing you the chi-squared distribution critical values. So at the degrees of freedom 2, I have 5.991. So I come here and say that the chi-squared critical is equal to 5.991. What am I going to do with this value? I can come to the normal distribution curve and put my value. So these values are positive, and therefore I'm going to take the value of alpha, which is 5% here, one-sided, and this is going to be our rejection ratio. So if the critical value x squared critical, which is 5.991, where is 5.86? 5.86 is outside. So 5.86 outside rejection region. So what does that mean? Fail to reject the null hypothesis. So that's how we do any problem. We deal with any problem that has chi-square test as a problem. So this is the data that you're given. You write the null hypothesis and the alternative hypothesis. Then from there, you calculate the expected values. From there, after getting the expected values, calculate the x squared, which is the chi-squared value, from sum of observed values minus expected values squared divided by expected values. After summing them, you get the x value, the x squared value, which is the chi-squared value, calculated. Then at the level of 5% level of significance, you go to the tables and calculate, and pick the critical value of x. Then you compare the calculated value of x squared and the critical value of x squared. So if it is outside the rejection region, then we shall fail to reject the null hypothesis. But if it was within the rejection region, we could reject the null hypothesis and adopt the alternative hypothesis.